Hi everyone, thanks for joining again. I wanted to do this video as a follow-on to a video that Salius did on modeling interfaces, and by interface I am speaking of the UML element that is more geared toward software interfaces. If you look in your palette section, you have this interface element here, and what you can do with those is add properties to those operations and receptions. And then in order to actually put that into play, you can use the interface realization relationship, and that can connect to either a block or an interface block. Conversely, what you would have is an interface or a part of a system that could require that interface, and that could be this interface block, and it uses the relationship called use in order to convey that this requires this interface. So this would be providing the interface through the use of this interface realization. This would be requiring this interface. This is somewhat to follow on to what Salius was talking about, and I want to point out maybe a few other things that I thought of as I was attempting to recreate what he did in that last video. What you can do with these is take the block and type the ports. These could be proxy ports, that could also be standard ports. If it were a standard port, which is what you have in your drop-down menu here. Standard ports, by the way, are being deprecated in SysML, and they're these ports that simply are called ports, but they cannot be typed by interface blocks. They can only be typed by blocks. So what I've done in this case is actually shown how you could use an interface block and you can type a proxy port with that. And then notice it pops out with the little lollipop icon. And that's to convey that this interface is a provided interface. It's providing this software interface. On the other side of that, you would see, if you type this proxy port, you would see the indication that that is required. Ball and socket is what that is called. And the socket, of course, is to say that it requires this interface. So what does that really mean? And then how could we possibly maybe simplify that for SysML a little bit, instead of using what began in UML, which is this idea of an interface that is more geared toward the idea of software interfaces and the functionality that they provide. So what I will do is essentially go back, undo this, and what we can show here is how we can do the same idea without using this setup, without using this idea of having an interface element at all, and without using this use relationship and the interface realization relationship. And one thing to point out, in Salius's last video, he copied this operation up to this block, but what's interesting about it is that the method of the operation needed to be in this operation. So if you were to take a method and assign it to an operation, this activity here is currently the method of this operation. If I were to actually assign that to be the method of this operation, it would no longer be the method for this operation. An activity or behavior can only be the method for one operation. So that's something that's interesting and good to understand, is that in that video, what you saw is that it was a copy and a paste, and it actually created a new operation, and it actually deprecated the use of this in that simulation. So this was not being used at all. And what you can do is really get rid of this idea altogether and do the exact same thing by simply having an operation that is placed on a block. In order to use that or call that operation, you can use a call operation action. So what's very important to understand about this, and this is what Salius showed in the video, was that the operation can be called from another context, and it needs to be called from another context unless it's some type of a message to self that it's calling its own behavior. So what you see here is part one, activities classifier behavior, is this activity here. This is a call operation action, and it's going to call the operation that is called operation name, and it's going to be called via port P1, which is the port that it's exiting. Now notice it has this indication here that the operation will be performed by part 2, and that is the case. However, we don't want to call the operation from the context of part 2. We want to call it from another context. And what we can do with that is actually send some parameters with that or send some data to the call. And in this case, what we'll do is actually send a string that simply says STC loves MBSE. We will send that with the call operation and the call to perform the operation. And then part 2 will perform that by executing this method. So this activity is assigned to the method portion of the operation. So if we look in the specification for that, what you'll see is the method here has this activity that is named the method of the operation. And that's what you see here. What will happen is that information that we passed it, the string that says STC loves MBSE, will be sent into this opaque action. And this opaque action will combine that text that we've then named user info and combine it by using an addition. When you perform additions with strings, simply puts the two strings together. So that's what you'll see come out of this is it'll say STC loves MBSE and digital engineering. That will be sent out of this reply or return parameter, and that will be then passed back to the part 1 context. So what is really neat about that is that you can simulate all of that, and you can also auto-generate the sequence diagrams, and that is really the approach to take for doing that. That is what Sally showed in his video as well. I wanted to add on and just drive the point home that this call operation action needs to be in the context of the requester of the operation, not actually who is performing the operation, unless you're wanting it to be some type of a message to self. So let's run the simulation and you will see this happen, and then we can auto-generate the sequence diagram. So we're passing the text into the call operation. It makes the call to part 2 to perform the operation. It's executing the method of the operation now, combines the strings. This is synchronously waiting for that, and then now pops out. And then we're simply assigning that string to a value property in the context of part 1. So what you'll see down here is that is now assigned as the runtime value for this value property back in part 1's context. So then the neat thing to do with that is to then run the simulation and auto-generate a sequence diagram, and you can see all of that in the view of a sequence diagram. So that happens very quickly. And what you'll see is part 1 sent a message, and the message contained the data for the input to that operation. Notice we have the name of the operation, we have its first input parameter, and we've passed it the data that says STC loves MBSE, and then after the colon here, we actually have the return, and that is STC loves MBSE and digital engineering. And then you see that that gets sent as the reply back to part 1, and in this case we have the invariant to show now this value property's value has changed. So that's when Cameo will identify that change by throwing the invariant on that lifeline to say, hey, this is from part 2, that's the name of our value property, and we're assigning this text to that value property. So that is a really neat thing that you can do. The video that Sally did is excellent as well. I just wanted to point out a few other small things that I noticed as I tried to recreate this. And those things, again, just being the operation that's calling needs to be in some other context. You'll see all of that makes sense when you auto-generate that sequence diagram, because part 1 really is requesting part 2 to perform the operation, but it's also passing it some data, and it did that using the inputs to that call operation. So I hope this might help complement that video a little bit. And if you guys have any questions, please feel free to reach out. Thanks.